Okay, welcome back to Waves Notes number 2. Today we're going to finish this up. I'm pretty confident this time in the second video. So we're talking briefly about the speed of waves, how those mechanical waves that require a medium, change based on what medium they're passing through. Now, real quick, different mediums, remember, solid, liquids, gases, what we're talking about, have different densities. The particles are either closer together or farther apart. And it's kind of funny. It's maybe the opposite of what you would think. So real quick to yourself, do you think a sound wave would travel faster through air, water, or iron? Solid or gas, liquid, or solid? And maybe the answer surprises you. It turns out that when those particles are closer together, a mechanical wave can pass between particles more quickly. And so the speed of sound increases in different mediums that are closer together. So in air, it's actually at its slowest. In water, liquid, it's faster. If you ever watch fireworks near a lake, it's really cool. You actually hear the sound twice when it comes through the water and when it comes through the air. I get to do that on my parents' lake. And same thing with a solid. It might not go as far, but it goes faster. So there you go. As density of a substance increases, the speed of the sound increases. And then loudness. We talk about sound waves a lot in terms of music. Music's a pretty big passion of a lot of yours, either if you make it or if you listen to it. So the thing that determines how loud something is the amplitude. Here's a picture of a quiet sound wave. Just something I drew. It's really funny when we talk about waves. There's actually ways to transfer between longitudinal and transverse. Sound waves are longitudinal, but we often draw them as transverse because it's easier to understand. So there's a conversion factor there that we're not going to go over. And here would be a loud sound wave. So the amplitude, how high the wave is, basically, how much energy the wave has as it travels along at that same speed. That's what determines how loud something is. We measure in decibels for amplitude and for loudness. If you've ever seen decibel scale, here's a quick measure. If you were to whisper to somebody, that might be at 15 decibels. If you were to hear a lawnmower, be right next to a lawnmower, that's at 90 decibels. And if you go to a concert, especially a rock concert or a more modern music concert, those things are at least at 120 decibels. By the way, anything over 85 decibels causes hearing loss. So that's why they do recommend you wear earmuffs when you're doing yard work or chainsaw work or anything like that. Actually, my aunt and uncle got these cool little things that are noise canceling, like AirPods basically, that they took to a concert with them, just that they wouldn't hurt their ears. They wanted to go to the concert, they wanted to have the experience, but they wanted to protect their ears, and there's devices for that now because concerts are too loud. All of you, I'm looking at all of you that have your music playing and I can hear it from the other side of the room. You have it too loud and you already have damaged your ears. Quiet it down. Quiet it down. Pitch is like how something sounds. I'm not the best at music at explaining some of this stuff. I have pitch and frequency generators to me that make more sense to me. High pitch is really, really high and low pitch is really, really low. Frequency or pitch is measured in hertz. A human hearing range is 20 to 20,000 hertz. Some of these are just cool facts, especially on these last couple slides, more so than on testable material. So we have this infrasound and ultrasound stuff. Maybe some of you have even worked with the ultrasound scene because older people get hearing damage. It just accumulates over time, especially if you go to concerts. And maybe some of you have tried playing some of those 18,000 or 19,000 hertz ringtones that some of your teachers can't hear. Maybe. Other animals have different hearing ranges. That's kind of cool to look at. Run out of time. That's why I just sped up because I promised I'd finish this one. Here's my last 2 slides. Sonic boom is just when a bunch of sound waves combine together. And here's a couple places it happens. And the Doppler effect, this is what the police use to measure speed for radars and stuff like that. It's just an apparent change as you're moving. There we go. There's the end of the notes. Have a good day.